Welcome to class today, geometry students, on this Thursday, November 7th. Hope you guys are doing well. Hope you're ready to learn some math today. And I think that's how I open just about every video, isn't it? You guys could probably quote to me how I start off every video. But I do hope you guys are doing well, and I hope you did well on your test yesterday. There will be a quiz next Wednesday, so please make note of that somewhere in your day timers. If you do that, you have nothing to turn in unless you're behind. You have nothing to turn in. There was no homework yesterday, and you had to turn your review sheet in yesterday if you wanted credit for that. Jason, you're missing this one assignment. Now, if you think you're missing more than that, then be thankful. This is all that I have. I went to your name in Sycamore earlier today and checked. This is the only assignment that you're missing, so if you'll please make that up. And remember, Jason and all you students, from now on, you get 5 bonus points on your quiz if you're all caught up on your homework when those quizzes roll around. And of course, that doesn't mean you can get behind on your homework. If you get behind on your homework, I am calling or emailing your parents, and you know that some of you have unfortunately experienced that. So, Jason, this is what you owe me. Welcome, Miss Haley Nicholson. Great to have you now as a Berean Academy Eagle, and I hope you enjoy your time here. My son, Mike Earhart, is actually in your sophomore class. Not a good influence. Please stay away from him. Bad kid. Bad kid. But anyways, I'm Haley. Glad to have you in class. And by the way, you other 4 geometry students, if you think that I've gone crazy and you're looking around the room for Haley, she is taking this course 3rd hour of the day. So she will not be in the room with you guys, but she will be taking the class. And please make her feel welcome. If you see this new young lady, please make her feel welcome. Now, I picked up your tests from yesterday at 3:30 in the afternoon, Wednesday, when I picked my son up. By the time I got home, and then we had supper and my family took off for church. I stay home on Wednesdays and do eBay orders and do videos like this, but there's no way I could get your tests graded in time before they got back from church so I could put them on the video. So tomorrow I will have your tests graded. We will go over those in class. I have some new headphones today borrowed from Mr. Harmon, so a shout out to Mr. Harmon there, and let me know. One of you students emailed me and said that there is some feedback on the other microphone I'm using. There's a buzzing sound, so let's try these. Let me know if it sounds better. Then lastly, one student has contacted me with their email. Remember, I asked you guys to start using a new email, and Haley, by the way, email me anytime, okay? My name is Mr. Earhart, and my email is Earhart, E-R-H-A-R-T, Michael, Earhart Michael, same name as my son that's in your class, Earhart Michael, at Juno, Juno.com. I asked you guys, and Haley, you didn't know this, but I'd like you to do it too. I've asked you guys to shoot me off an email that just says, hey, or hi, or what's up, or whatever. And I will take your email and I will save it in my email address book. So only one of you has done that so far, and that's been Martin. So thanks for doing that, Martin. Please, the rest of you do that. Call me or email me anytime that you need to. Haley, my number is 706-965-2675. If we're not here, leave a message. I will call you back, but call or email anytime that you need to. Email is probably the best way to get a hold of me, but feel free to call if you want to. So only one of you has done this, and I really need to get those emails. Okay, I need you to get out your notebooks, your books, your pencils, pens, calculators, and Haley, if you don't have a geometry book, you'll probably want to pause the video and tell Mr. Harmon or whoever your teacher is that you need the McDougall, M-C-D-O-U-G-A-L, McDougall-Littell geometry book. McDougall-Littell geometry book, okay? And if he doesn't know which one that is, Mrs. Walker would know, all right? So let's get started right away, and let's see if we can't accomplish some math. Oh, and one more thing, by the way, Haley, not picking on you, but one more thing. I think you were coming from a block schedule, so there's a pretty good chance you're going to be ahead of us, okay? Now, every teacher and every book does go in different order, in different orders, so we might be in a different place, and maybe this will be new stuff to you, but more than likely you've had this, so just hang in there, take notes, and be thankful if it's something you've had already, because as far as I know, you will be in this class the whole year since we're not on block schedule, but that could happen to where you're seeing stuff that you've had before. Okay, students, here we go. You do not need to write this down. Just watch. On Monday, we studied something called the angle bisector theorem. I'm just reviewing for a second, okay? That was lesson 5.6, part 1, all right? Now don't write this down unless you want to. And what I said to you is this. If we have an angle like this, like we do, and we have a ray coming off of it like this, like we do, and I said if this angle here is congruent to this angle here, and if we have a point that falls on this ray right down the middle, and if this is a right angle here, and if this is a right angle here, let's go ahead and call this A, B, and C. What I said to you is AB is congruent to CB. Alright, that means this segment here is congruent to this segment here. Now again, what that's called is the angle bisector theorem. And again, if we have an angle with a line coming out of it dividing the angle, if these two angles here are congruent, and if there's a point on this line right here, and if we have a right angle here and a right angle here, then this segment here will always be congruent to this segment here. And we call that the angle bisector theorem. That was just a little review, okay? Now I would like you to write this down, please. We're going to go ahead and finish lesson 5.6, part 2 today. The heading, please write this in your notes. And by the way, I forgot to change the date on this. And don't think I just whip up old notes from last year. I go through and change these. I changed these a lot, actually, from last year, just today when I looked them over. But the date today, of course, is the 7th, 11/7/13. And the heading is Perpendicular Bisector Theorem. Perpendicular bisector theorem. The lesson is 5.6, part 2. We've divided this lesson up here into 2 days. Okay, so please copy this in your notes, and let's go ahead and get started. I'll be saying a lot of things to you, Haley, as you get used to my teaching style. I go fast on purpose because here's why. It's really hard to speed a video up if I'm talking slowly, but you can always slow it down by pausing it and rewinding it if you miss something. So I do go fast on purpose, and you are able to rewind or pause the video if you need to. Perpendicular bisector theorem, lesson 5.6, part 2, November 7th. Please write this in your notes. Theorem 5.4. The perpendicular bisector theorem states, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Let me read that again, then I'll give you a picture of it. If a point is on the perpendicular bisector of a segment, then it, what is it? The point. Then the point is equidistant from the endpoints of the segment. Now I think a picture is worth a million words, so here we go. Let me give you a picture of this. Now again, I go fast, pause the video if you need to. I would like you to copy these 2 lines in your notes, please. Make sure the red line divides the black line right in half. So this point right here should be in the middle of this black line. Okay, right in the middle. So this red line right here should divide the black line in half. Okay, so please go ahead and copy this in your notes, this right here. Alright, now here is what the theorem is saying. Please take some really good notes on this. Alright, what I want you to do is go ahead and draw these black lines right here. Alright, now here's what I want you to get. Follow the if part. If a point is on the perpendicular bisector. Now please stop right there, students. Perpendicular bisector. This red line has to be perpendicular, so put a right angle right here. Got it? And of course, if there's a right angle there, you understand there's one here too. Now you don't have to mark both of them. You can if you want to. You don't have to. All right? And then it says not only is this red line perpendicular, it's a bisector, and that means it cuts this other line in half. So go ahead and put a slash here and a slash here, because these 2 segments are congruent. And by the way, we may as well go ahead and give some names to these points. Let's say A, B, C, and we'll call this point right here D. Alright? Now, so let's review. If a point is on the what? Perpendicular bisector. So, perpendicular, there's the 90-degree symbol, perpendicular. Bisector, that means this red line cuts AC right in half. Then this point, by the way, the point we're talking about in this diagram is point B. Point B. Okay? So, if a point B is on the perpendicular bisector of a segment, then this point B is equidistant from the endpoints. Well, here's the endpoint, and here's the endpoint. All right? So what we can say is this. We can say that AB is congruent to CB. Now, students, if you're a little lost, let me say this a little easier for you to understand. Are you ready? Here's what this theorem is saying. Are you ready? Really easy. If you have two lines intersect like we do here, you ready? 1, 2. If you have two lines intersect, okay, and then you have lines that connect the endpoints like this. If you have a drawing like that, and you have a right angle here, and congruent symbols on this line here, then this segment here will always be congruent to this segment here. I think you see now why I reviewed and went over this real quick. I don't want you to get the two confused. This one here is if you have an angle with a line dividing the angle, if this angle is congruent to this angle, and we have a 90-degree angle here and a 90-degree angle here, then this segment is congruent to this segment. Now this is a little different. What I'm saying to you here is this. If I have two lines intersect, 1, 2, in such a way that, hold on a second, if I have these two lines intersect and then lines drawn from a point here to the endpoints in such a way that I have a 90-degree angle here and congruent lines here and here, then always this segment here will be congruent to this segment here. Now we're going to review that, okay, and we're going to give you homework tonight to help you learn this, but that's what you need to know. That's really, really important. Now I'm going to do something to you today that's pretty tough, and you're going to be scared. Okay? No, I'm not going to ask you to get up in front of the class and do a proof. I'm not going to ask for anything like that, but I'm going to have you do something you've never done before, and it's not going to be easy. But anytime you try something new, there's always going to be a challenge, and we understand that, okay? So, we're going to do something we've never done before, and while I'm giving you bad news, let me go ahead and give you worse news. I'm going to put this on the next test. So here it is. Some of you will just memorize it, which is fine. It's not that hard to memorize. And others of you will understand it, and you'll just know it because it's easy to understand. Whatever category you fall in is fine, but here's what we're going to do. We're going to prove our first theorem ever. So I want you to go ahead and make a note somewhere in your notes that we are now going to prove Theorem 5.4. Now take some really good notes, please. I care about y'all. I tell you that all the time. Love y'all. I want to help you, okay? But you've got to take some really good notes. You can't get discouraged. You got to hang in there and work hard and ask questions if you have questions, okay, by contacting me now or by watching the homework help videos. Now, here we go. Please watch what I do. The first thing you want to do on the test, the next test we take, probably on the quiz this Wednesday, I'll have you do this too. So this will be on the quiz this Wednesday. I'm going to say prove Theorem 5.4. And you know what I'll do for you? I'll list it out. I'll type it for you. So all of this will be given to you. The first thing you do is you draw a picture of what you're going to use to prove this proof. So go ahead and draw a picture. It'd be something like this. You draw a line like this, and then draw a line that cuts it right in half. Well, that was a good line. And then go ahead and draw lines like this. There we go. And I would encourage you to use the same letters I'm going to use. You don't have to. A, B, that's not a B, C, D. Okay? So first thing you do is you draw a picture of what you're trying to prove. Is that okay? Everybody see it? Now listen to me. Your if part is your given. Your if part is your given. Are you ready? So here's what I'm going to write for my given. I'm not sure why I put a P. I guess because I don't know how to spell. All right, here we go. Here is your given part. Are you ready? You write this down now. If a point is on the perpendicular bisector of a segment. So we're going to write down this. Your given is BD is a perpendicular bisector of AC. That's your given. Your if part is always your given. Got it? Your if part is always your given. Your then part right here is what you're trying to prove. And it says, then it is the point, and the point is B, then it is equidistant from the endpoints. So what you're trying to prove is that AB is congruent to CB. That's what you're trying to prove. Now look, listen to me so carefully, please, students. Listen to me. Some of you are already getting this. Some of you are like, wow, I'm just going to have to memorize this. And whatever category you fall into, you can do this. It's not a long proof. I mean, look, guys, how many of you cannot remember to draw a picture like this? Draw a line up, triangle, triangle, triangle. There you go. And then how many cannot remember that the if part's the given? So I'm going to write BD is a bisector of AC. And then you can read the then part. Point B is equidistance from the endpoint. So AB has to be congruent to BC. And that's what you're trying to prove. So you can do this, okay? All right. This is not going to be easy, but you can definitely do this. Now, that's what we're trying to prove. Now, what I'd like to submit to you is this. There's no way to prove that this segment here is congruent to this segment here. There's not? No, there's not. Not unless we prove this triangle here, we'll call it triangle 1, is congruent to triangle 2. Remember, once you state that two triangles are what? Congruent, you can then state that all of their parts are congruent. So what we're going to have to do to accomplish this proof is to state that these two triangles are congruent. Okay? Now, I think I've got a way to do this, and let's see if we can't just brainstorm and use some common sense here, okay? In fact, what I'm going to do is I'm going to open up another page here, so bear with me for 1 second, and then go back down to here. I'm going to take this picture right here, if it's okay with you guys, and that's not what I wanted to do. Haley, you'll get used to this. I'm not exactly technologically savvy here. All right, there we go. And let's see if we can't grab this whole thing. Oh, we forgot a letter, didn't we? Get back here. All right. All right, now let's see if we can't. There we go. Now there's our diagram. Let's see if we can't do a little brainstorming real quick. Can we do that, guys, please? Remember, we're trying to prove that AB is congruent to CB. Now we can do this. Really stay with me, okay? First of all, let's call this angle 1 and we'll call this angle 2. And Haley, I don't care if you do that. You can number angles. That's fine. Somewhere in my proof, I've got to state that angle 1 is congruent to angle 2. Now how can I do that? Well, somewhere I've got to state that angles 1 and 2 are what type of angles? Right angles. And once I state they're right angles, I can state they're congruent. Can I not? Sure I can, definitely. Now, somehow I've got to state that AD is congruent to CD. So far I want to state that this angle is congruent to this angle. I want to state that this segment is congruent to this segment. Hey, look, I can state that BD is congruent to BD. So somewhere I want to state that BD is congruent to BD. Now, if I state all of that, and Haley, I'm not sure where you're at in your geometry. Hopefully you've had this already. Guys, look, now that I've stated all of this, look what I have. I have side, then angle, and then side, congruent to side, angle, side. So I can then definitely state that triangle ADB is congruent to triangle CDB. By what reason? Side, angle, side. And then I'm done. So this is the approach I want to take. Are you ready? Here we go. So let's come over here, and only because I'm running out of room, you should have already written this down. I'm going to go ahead and delete that to give myself a little more room. And we're going to do a 2-column proof here. So over here are my statements. I'm going to put S. Here's my reasons. Okay, number 1, we always put our given. Okay, and our given was, let's see, BD is a perpendicular bisector of AC. So BD is that's like number 1, doesn't it? Perpendicular bisector of AC. There we go. And what's the reason we can state that? It was given to us. It was given to us, definitely. All right. Now, here we go. Are you ready? I'd like to state that angle 1 is congruent to angle 2, but I really can't do that until I first state the angles are right angles. So I can do that. I can state that angles 1 and 2 are right angles. How can I do that? Well, guys, come on. What's given to us? We know that BD is what? Here it is. BD is what? Perpendicular. If BD is perpendicular, then I can say that angles 1 and 2 are right angles. How do I know that? Definition of perpendicular bisector. The definition of a perpendicular bisector is the two lines are perpendicular. Okay, so there we go. Now that I've stated angles 1 and 2 are right angles, I can definitely state that angle 1 is congruent to angle 2. What's my reason for that? Do you remember? All right angles are congruent. That's my reason. All right angles are congruent. So check that off or cross it off, whatever. We're good. Now somewhere I've got to state that AD is congruent to CD. Now here's AD right here. Here's AD. and here's CD. Somehow I've got to state they're congruent. Oh my goodness, I've got it. Did I not state in my given that BD is a perpendicular, what's this? Bisector. BD is a bisector of AC. BD is a bisector of AC. That means BD cuts AC in half. So if BD cuts AC in half, then I can definitely state that AD is congruent to CD. Definitely. So I can definitely state that AD is congruent to CD. And what's the reason? Same thing as number 2, guys. Definition of perpendicular bisector. Do you remember what the definition of a perpendicular bisector is? I can't quote it word for word, but it's something like a line that divides, that is perpendicular to a segment and intersects at its midpoint. Something like that. A perpendicular bisector is a line that intersects, it is perpendicular to a segment and intersects the segment at its midpoint. And so basically what we're saying is this is the midpoint. And if that's the midpoint, that means it's in the middle. And if that's in the middle, then AD is congruent to CD. So I can definitely state that AD is congruent to CD, definition of perpendicular bisector. So I can cross this off. Now I can definitely state this. That's the reflexive property. I mean, there's no doubt that BD is congruent to BD. It's the same segment. So BD is congruent to BD, and of course that would be the reflexive property. The reflexive property. And reflexive is good enough if you just want to put reflexive. And now you're ready to state that the two triangles are congruent. So here it is right here. Let's just grab it and drag it over there. Save some time. There it is. All right, there it is. Triangle. I'm going to cross this off because, well, actually I'm going to drag it over here. Here we go. Triangle ADB is congruent to triangle CDB. What reason? Side angle side. We stated this segment here is congruent to this segment here. That's your side. We stated this angle is congruent to this angle, and we stated BD was congruent to BD. So there it is. Side angle side congruent to side angle side. Now don't forget what you were trying to prove. You were trying to prove that AB is congruent to CB. Well, let's see if we can do that. Come over here and look at what you stated. Yep, here's AB. Here's AB, first and last letter, and CB, first and last letter. So I can definitely state now AB is congruent to CB. Number 7, and the reason would be corresponding parts of congruent triangles are congruent. CPC, TC. Mr. Harris, 7 steps. Well, guys, we can handle that. We'll see how you do on the quiz with this, okay? And don't forget, I'm splitting your tests up in 2 different days now, all right? Guys, it's a short video today. I know when I say that, you start cheering right away. I've got one more problem to give you and then a pretty small homework assignment. Now, Haley, you're new to the class. You can ask the students. They're kind of laughing, I'm sure. The homework assignment is never this small, so please don't get used to that. This is it, guys. So there's the proof. You need to know that. Let's quickly throw a homework problem at you right here. I mean, an example. Students, go ahead and put this in your notes. Now, you do not need to draw this drawing here if you don't want to. Instead, you can just write page 274, number 3 at the bottom, open your books to that page, and write this in your notebook so that you know where the problem's coming from. Or if you don't want to do all that, feel free to draw this drawing. That's fine. Okay, here we go. Are you ready? Here's what I told you. Are you ready? I told you that if 2 lines intersect, let me get a different color of ink here so it shows up better. I told you if 2 lines intersect, and there they are, 2 lines intersecting, and then I said after they intersect, if you have a point off of this line, here, going to the end point and going to the end point like that, if you have all of that, which you do, you have all of that, and then you have it in such a way that you have a right angle here, which means you have one here too also, of course. And I said, and if this segment's congruent to this segment, and it is, you have an 8 and an 8, which means those 2 segments are congruent, then what you know for sure is this diagonal line here and this diagonal line are both congruent. So if they're both congruent, we can definitely set up an equation and solve. We know that 2x plus 5 equals x plus 10. Now let's go ahead and solve for x. I'm going to bring my x over here, and when I do, it's going to become a negative x. And now that x is gone. And then I'm going to bring my positive 5 over. And when I do bring it over, it's going to become a negative 5. And now it's totally gone. So let's see what we're left with. 2x minus x is 1x, or just x. 10 minus 5 is 5. Now that's not your answer. Look up here. If the directions would have said solve for x, then you would be finished. But the directions did not say solve for x. The directions said find the length of EF. Well, here's EF right here, 2x plus 5. So where that x is, you've got to put a 5. Now remember, that's not 25. That's 2 times 5 plus 5. And so 2 times 5 is 10, plus 5 is 15, and here's the answer right up here covered up. The answer is 15. Okay? All right. Now I hope you're doing okay with this. Enjoy the short video. Haley, it won't normally be like this. You can ask the students, and homework won't usually be this short, but we're finishing up this lesson. We are going to look at lesson 5.7 tomorrow, and then when we take our chapter test over chapter 6, these 2 lessons from chapter 5 will be on the test. Okay, so we will put these on the other test. All right, here's your homework assignment. Now here's how we do things, Haley. There's a homework help video you can watch for every homework assignment that I give you. So the website that Mr. Harmon's told you to go to, teachhim.com, I forget what the rest of it is, / Brian Academy Geometry, but he should have given all that information to you. The password, math is awesome, math space is space awesome. You look for a video. Now let me go back here and show you something real quick. Haley, you need to see this. The lesson was called Lesson 5.6 Part 2. And so the homework assignment that goes with this would be geometry, what did I just say? Geometry 5.6 Part 2, and then the word homework. And there's spaces through here and everything, okay? And that's the video you look up. So whatever the lesson number is I teach that day, the video will be the exact same thing plus the word homework. And you'll find that video right now. If you're watching this video and you go to the webpage, you'll see this video. Students, have a great day. I hope you're getting this. Call me or email if you need. Oh, Jason, your makeup test. You do not have to take it by today if you don't want to. In fact, actually, I mentioned going over that test by Friday. We won't be able to do that. And Jason, please don't rush. Please do not rush. Take your time. We will have to wait for you to finish your test first. Now, I'll go ahead and grade them and post your grades on Sycamore so you'll know what you've made, but I will not be able to pass those out until she's taken the test. So, Jason, you have until Friday to take the test. If you need more time than that, please let me know. And if you're going to let that test count for your quiz grade that you missed last week, let me know about that, and that's fine also, okay? Have a great day. Call or email if you have any questions. Please go ahead and work on your homework now at this time, and use the homework help video if you need to.